Hi everyone, in this video you're going to learn how to factor quadratics, like with coefficients of 1. I got into this briefly in the previous video, but this video is mainly just going to be me elaborating on it, right? So the first question that I'm going to solve for you guys is x squared plus 5x plus 6 is equal to 0. Now, how I'm going to solve this is using the idea of roots, right? So in a previous video, I went over the rule that in the factored form, which is x plus r times x plus s equal to 0, that where these are what you're going to use to find your roots. We know that r plus s has to equal the coefficient of the linear term. So the linear term is 5x, so the coefficient is equal to 5. And r times s has to equal the constant term, which is equal to 6, right? So this is what we know. And what we're going to do is we're just going to find two factors that make this equation true, or make this relationship true, right? So what are two factors that add up to 6? Add up to 5 and multiply to 6. Well, to 6, there are only a few factors, right? I'd like to write out all of the factors. So you can either do it as a table, but I prefer to do it as a factor tree, as an unsimplified factor tree per se. So if I'm going to elaborate on that, that would look something like 6 is equal to 2 times 3, or 6 times 1, right? And out of these two factor pairs, what we see is that it has to be 2 times 3, because 2 plus 3 is equal to 5. So now what we're going to do is we're simply going to write this in factored form, because now we know what r and s is equal to. We just need to write it in factored form. So that's going to be x plus 2, because if we equate r is equal to 2, it's equal to 2, and s is equal to 3. If we equate it to that, then all we're going to have to do is we're just going to have to substitute it. So x plus 3 is equal to 0. And now what we're going to do is we're going to use the zero product rule to factor it out. So for solution 1, I always like to denote our solution by S1, and that would be x plus 2 is equal to 0, right? The reason why is because it would be using the zero product rule, which states that a times b is equal to 0. If a times b is equal to 0, then either a or b have to equal 0, or both have to equal to 0. And since we don't know which one is equal to 0, it's best to just try out both. And that's pretty much how you factor a quadratic. So then what you're going to do is we're just going to solve this equation by subtracting 2 on both sides, and we're going to get x is equal to negative 2. That's solution 1, right? And then solution 2 will show you that x plus 3 is equal to 0, right? So when you subtract 3 on both sides, we're going to get x is equal to negative 3. These are your solutions for this quadratic, right? And you can double check that by substituting your values back into the variable, right? So let's just substitute our variables back. This is one of the best practices, and it's definitely something you should make a habit. So how I like to substitute my variables is by making my exoskeleton, as my mom calls it, an exoskeleton of your equation. So we know that the quadratic consists of a variable. I like to leave my variable blank because it's an exoskeleton, plus that, plus my second variable substitution, plus 2, right? Or 6, sorry, plus 6. Then I go back in and I substitute my values. So I choose to substitute this as negative 2, and voila. So let's just solve this. So negative 2 squared is equal to 4, Oops, I'm missing a number here. I believe this number is supposed to be 5. So plus 5 times -2, which would be -10. So you can just cancel out the positive to become a -10. And plus 6 is equal to 0. And then 4 minus 10 is equal to -6. And when you add on 6 to that, it gives you 0, which proves to be the correct answer. The second solution that we need to check is, again, -3. So I'm going to make my exoskeleton again without making the same mistakes I made last time. Plus 5 times that plus 6. This is our original equation. Then what we're going to do is we're just going to substitute in -3 and -3. Okay, so we know that -3 squared is equal to 9 because negative times a negative is equal to a positive. And squares are usually never um, a negative number unless we're talking about imaginary numbers, right? Like unless we're talking about I. In that case, it's different. But we're not talking about I here. This is just a regular real number. So it's going to always be positive. Then what we're going to do is we're going to multiply 5 times 3, which is -3. So that's -15, and this is plus 6. And it's equal to 0. So 9 minus 15 is equal to -6 plus 6, which I'll give you 0. And that is true. Another way you can recheck this is by graphing it. But the reason why I don't recommend it is because usually on tests, you're not allowed to use graphing calculators. But for now, I'm just going to X out these because it contains the solutions to the following 2 questions. But for now, the equation that we wanted to graph was x squared. So if you're on a computer, how you do that is by clicking on Shift and caret if you're on Dell computer, or you just click Shift 6, and that will give you a hyperscript. I don't really know the shortcut for Mac, but I'll put it in the description below. And then plus 5x plus 6 is equal to 0. And as we covered in the last video, we said that the x-intercepts of your quadratic will always be the solution to your quadratic. So the solutions are -3 and -2. So that's how we know we're correct and we solved it correctly. So for this question, for question number 2, let's solve question number 2. So nothing really changes here. We know that r plus s, or the numbers that we're factoring, that they have to equal r plus s has to equal -3, and r times s is equal to 2, right? So when we know that this is true, we just have to find factors that make the equation true. So one thing that we have to notice here and be a little bit more cautious about is that this number, the sum of r and s, is -3. That means we have negative numbers in the hood, right? So if our product of our numbers is positive, but our sum is negative, that would mean that there has to be 2 negative numbers, or both our roots need to be negative numbers, or both our supposed roots need to be negative numbers, because otherwise, when multiplied, you wouldn't end up with a positive number, right? So for 2, since it's a prime number, you only have 2 factors, which is 1 and -1. I mean, 1 and 2. And since it's supposed to be, the sum is supposed to be negative, it's just going to be -1 and -2. Now all we need to do is we just need to put it in factored form. So that's just x minus 1 times x minus 2 is equal to 0. And again, using the zero product rule, we know that our solution 1 either has to be x minus 1 is equal to 0, which when we add 1 on both sides, we just get x is equal to 1. Then for our solution set 2, or solution number 2, we know that x minus 2 has to equal 0, and we add 2 on both sides, and we just get x is equal to 2. Now, again, we have to make it a habit to double check our answers because quadratics can be quite tricky at times, especially when you're dealing with coefficients that are greater than 2, right, or greater than 1, right? So you have to be very careful. And what we're going to do is we're just going to substitute our values in by making our exoskeleton, right? So times dot squared, the numbers that we're adding in are, I believe, negative 3. Is it negative? Yeah, it's negative 3. So it's times minus 3 times x plus 2 is equal to 0. This is our exoskeleton. So let's go back and fill in all of the numbers. So this is going to be 3, 3, and let's solve. So 3 squared is equal to 9, and 3 times negative 3. Hold on. I think I got the wrong number. It's 1. Hi, my apologies. My mind is still lingering for the previous problem. So let's substitute in 1, the correct solution to the quadratic. And we're going to get 1 squared is 1. Negative 3 times 1 is equal to negative 3 plus 2 is equal to 0. So 1 minus 3 is equal to negative 2 plus 0. 2 is equal to 0. And that is correct. Then let's make our next exoskeleton, which is squared minus 3 plus 2 is equal to 0. Then we're going to substitute in all of our answers. So that's going to be 2, 2. And when you get 2 squared is equal to 4. Negative 3 times 2 is equal to negative 6. And that's plus 2 is equal to 0. And you get negative 2 by 4 minus 6 is equal to negative 2. Plus 2 is equal to 0, and that is true. So, okay. There we go. The pointer is really thin, so sometimes I have trouble looking for the pointer. So yeah, let's just check it by graphing this time. So our equation was x squared minus 3x plus 2 is equal to 0. Great, so let's check our roots, which is 1, and this one is 2. So we have the right roots. Okay. So now what we're going to do, finally, is we're going to factor our last quadratic. The only difference here is that there are 2 negatives now. So all we need to do is we're just going to know that both of our factored form numbers, or r plus s, is equal to negative 5, and r times s is equal to negative 6. Right, so now we're going to, I usually always work with the product number. I forgot to mention this earlier. It's because there are fewer sort of possibilities in negative numbers in your products than there are sums, because for a designated number, there are a lot more sums than there are actual product factors, right? So let's just work with the factors here. So negative 6. We can have, since both numbers have to be, only one number has to be negative in order for our solution to be negative, we can just work with that. So we know that it can either be negative 1 and 6, negative 6 and 1, or it can be negative 2 and 3, or negative 3 and 2, right? So out of these solutions, we can look for a solution, right? So we know that it's not negative 1 and 6, because when you add them together, you're going to get a positive 5, and we want a negative 5. We know that it is 6, negative 6 and 1, because when you add 1 to negative 6, you're going to get negative 5. So this is our solution, we know, but let's just make sure that we didn't do our arithmetic wrong. Right, so negative 2 plus 3 gives you positive 1, so that's not our answer. And negative 3 plus 2 is equal to negative 1, so that's not our answer, so we know that this is our answer, right? So all we need to do is put it in factored form. So x minus 6 times x plus 1 is equal to 0, right? And now we're going to solve according to the zero products rule. So our first solution is going to be x minus 6 is equal to 0. Add 6 on both sides. We're going to get x is equal to 6. Then our solution 2 is going to be x plus 1 is equal to 0. So you subtract 1 on both sides to get x is equal to negative 1. So these are our solutions. Let's just double check our arithmetic by doing some more algebraic solutions, right? So this time, hopefully not substituting wrong. I'm going to first switch this over a bit. It's taking up my space. Uh-oh. There we go. So let's make our exoskeleton first. So that's equal to this squared minus 5 squared, 5 minus 6 is equal to 0. Right, let's go back substituting our solution of 6. Okay. So 36 squared is equal to 36. Negative 5 times 6 is equal to negative 30. And when you subtract 6 is equal to 0. So let's just make sure 36 minus 30 is equal to 6. Minus 6 is equal to 0. Perfect. Right? Okay, I apologize for the background noise. So that's correct. Then let's move on to our second one from our exoskeleton of this squared minus 5 minus 6 is equal to 0. Right? So then what we're going to do is we're going to substitute negative 1, negative 1, and we know that negative 1 squared is equal to 1 minus plus a negative 5 times negative 1 is just equal to 5, and minus 6 is equal to 0. We know that's true because 6 minus 6 is equal to 0. Right, so perfect. Finally, let's check with graphing. Right, so let's go to graph decimals x squared plus, minus 5x minus 6 is equal to 0. Right, so if we check, we know that 1 is negative 1, one root is negative 1, and another root is positive 6. Okay, so that's it for this video. Thank you so much for watching. And if you guys have any questions, please do put them in the Google form that I'm going to give you guys in the description. So yeah, thank you so much, guys, and bye.